Hi there. I got a request to do the opposite of my engineer to designer video. Go the opposite direction, designer to engineer, because you've discovered you can make all these cool things, front-end apps, with just a few AI prompts. And maybe you're wondering, like, how does this all work underneath? It's going to take a long time for you to understand that. It took me a long time too. That's why I have the book, How to Speak Machine, that's available to you. It is a simple expression of computer science that I hope might be useful to you as you try to figure this out. I think, though, I like to try to make videos when I can. So thanks for tuning in, and let's see if I can make something useful to you. I want to talk about bits today. Ready for that? Bits? Here we go. So bits are basically, let's see here. I have gotten this all ready here. One second. Okay. I made some letter. Okay. So this here is a representation of 8 bits. Got that 8 bits. 8 bits are, let's count them again. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8. And I can set them to be 1 or 0. 1 or 0. You see that? 1 or 0. Now the cool thing about bits is that first off, you discover a lot of things. There's a lot of language used in computers that only comes obvious to you when you run into problems. So let's find problems. So here is 4 bits. 0, 0, 0, 0, 0, 0. That represents 0. Let's flip them all. This represents 255. You might be asking yourself, what about 256? It turns out that, 0 to 255 means 256 numbers. Let me count them on screen for you. You see them? Okay, so 256 numbers can be represented by 8 bits. 8 bits, right? And it's pretty cool. You can start with 0. By the way, this one here is called the most significant bit over here. And this is the least significant bit. I mean, that sort of depends upon where you're pointing. Least significant bit, most significant bit. What does that mean? It means that if this is flipped over here, 1, I can read that as 00001. 1 is turned on, and that is 1 times 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. That means 128. So this means 128, that's the most significant bit turned on. You gotta keep remembering that maybe you're maybe dyslexic. You think that this is the first one. I mean, you're gonna fight over which is the first one. So that's why you have to say this is the MSB. MSB, when it's flipped on, it means 128. And the LSB, when flipped on, means 1. Okay, so let's show you something really cool. In the world of bits, you can do something called shifting bits. So I can shift this bit over. And now the number is, right back here it was 1. Now it's 2. Now if I move this over here, this represents 4. And if you notice, as I move this over, this becomes 8. Do you see how it's, as I move it to the most significant bit, it's basically doubling in size. But the same way, I can shift the bits to the right. And what happens is I'm dividing by 2. Pretty cool, huh? I shift the bits. I can multiply by 2. I can shift the bits this way. It's dividing by 2. So that's a kind of simple example of how on the computer we love 2. 2 is awesome. Okay, now I think you might be a little bored by now. So let me actually take you to another level. Let's say you want to represent the most famous phrase on the computer. The first computer program you write is usually called a hello world program. All these bits over here, right? And you're like, how do we use 8 bits to represent this word? First off, you're going to use 8 bits to represent H, 8 bits to represent E, L, L, O, don't forget space, and WORLD. So that's 1, 2, 3, 4, 5, 6. Don't forget space. 7, 8, 9, 10, 11. So you need a total of 11 bytes to represent the entire hello world string. And if you are a computer person out there, you're saying, wait, he forgot the last, the last invisible character, which is usually called null, but let's save that for your future nerdliness. Okay, hello world. So how do we do this? Well, there is something called ASCII, A-S-C-I-I. It is the standard that translates the 8-bit numbers into characters. If I want to represent hello world, I first gotta cook up the number 72. So it's like playing bingo. So what the computer has to do is like, I need this one turned on, and I need this one turned on, and lo and behold, that is the number 72, which means, ta-da, H. I did it. It felt pretty good, right? Let's put H right there. H, okay, did it. And then, if you want to do E, that's going to be 69 is the ASCII decimal representation. So we're going to flip this one. We're going to flip this one on. There you go, and that. Okay, that is the number 69, stands for E. So let's put E right here. Okay, we did. Now we want to do space. Space is invisible, but super important. 32. 32 is a number for space. Let's make it 001. We flip this on, and then there we go. Isn't that good? Look at that. You know, when you have bits and you have like just one like that, oh, it's beautiful. So what we were able to do here is spell the word hello world. Okay, just like a Wes Anderson film. Okay, there we go. Hello world. We did it. Okay, so what did we achieve doing? We realized that 8 bits are fundamental to computers. When we have 8 bits, you got to figure out which is the least significant bit and the most significant bit. I guess the first person there gets to say, I called it, least significant bit is over here on the right. But don't forget, someone might declare it differently, and then all your numbers will be wrong. You can express any symbol 256 variations of ways. Those could be numbers, 0 to 255. If you wanted to be like radical, you could change it to 1 to 256, where you would have to make the 0000 represent 1 and the 11111 represent 256. But then someone's going to say, where's my 0? And I don't want to be there when someone asks for your 0 and you don't have it. So 0 to 255, part of the 256 available numbers, we use ASCII to define the different characters, uppercase, lowercase, punctuation, etc. If you're asking yourself, where did an emoji come from? There's so many emoji. How do all the emoji fit in 8 bits? You are right. They do. Now, where do they go, you think? Are they invisible? Are they hiding somewhere in the bits? No, it's quite simple. You may have heard of 16-bit computing, 32-bit computing, etc. We're just adding more bits, adding more permutations, and by doing so, we get to count much bigger numbers. And in bigger numbers, bigger numerical spaces, we end up with the power of representation of different discrete items. And before we go, when you think about large language models, artificial intelligence, why does this matter? It's because the foundation is the bits, the bytes. And when the bytes come together, they become words. When you have more bytes, they become sentences. And we're synthesizing bytes all the time. Don't forget, images are represented in the same way. Everything goes down to bits and bytes. Okay, if this was useful to you, please press whatever you call it, thumbs up. If I get to more subscribers, I'll keep making videos. If I don't get more subscribers, I guess I should stop, but I'll probably keep going. But if you want to keep cheering me on to do this, please subscribe to the channel, and I will be motivated to publish more videos like this. Okay, thanks. Bye-bye.